Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Wi-Fi 7, the new hype. So let's dive deep into it. So what is this puppy? This is Wi-Fi 7. So you have to understand everything like that, like Bluetooth, Wi-Fi, USB, things of this nature generally have a associated body who's responsible for making everybody play nice with everybody else. That's how we have this world functioning. So Wi-Fi has Wi-Fi Alliance. That's basically a body that is responsible for making sure what everything means, which protocol would be used, how security will be managed, how voltage, current, amp, circuit design, all of that. Like somebody who has to design it, that's their job. Now, before they release anything, for example, let's say Wi-Fi 7 has been just announced in 2024. Okay, awesome. Does not mean it was announced today. That means before this final certified stamp was created, they created what we call draft. Generally, drafts are created 1 year or sometimes few months ago before this final evaluation, and draft is sent out to manufacturers. And there is a bit of back and forth where it's like, oh, we do not think this can be implemented in silicon quite effectively, or like, electromagnetic spectrum would not play nice with this function. So there is a feedback loop between like new idea being baked in the hardware, then the hardware giving a feedback to the alliance, and then alliance giving the final stamp. This Wi-Fi stamp is final right now. So this officially have a name 802.11be. Yeah, just call it Wi-Fi 7. So what is new here? You have to understand, this is the time we go try radio. So we have 2.5 gigahertz radio, 5 gigahertz and 6 gigahertz, and all are default now. However, the 6 gigahertz is a bit situational, meaning the 6 gigahertz bandwidth would be dependent on region. As of now, when I'm making this video, India has not standardized that part yet, so I do not have that information. However, you have to understand, if same brands of manufacturer can give you a router, same hardware, it will behave differently in EU, it will behave differently in America. It's like, why? Well, that 6 gigahertz band, that spectrum is used by way too many other things. For example, mobile phone backhaul communication. Basically, when you see two microwave towers that are communicating between them, they many times use same frequency. Many times airport radar, many other things have way too close bandwidth to that one, meaning you do not want those priority services to be affected by commercial, basically normal everyday civilian use. So that's why we have allocation. That's why every nation has a radio body who's responsible. It's like, hey, make sure this band is not interfered with because it's for, let's say, FM radio. Do not interfere with this one. This is police radio. Do not interfere. That's how it is. So if you go into Europe is like from 5925 megahertz. That slice, we start your radio from that hertz. You can go up to 6425 megahertz. We're not going to interfere. So basically, EU is going to give you a good slice chunk of a space in spectrum where they will not make it illegal. Now, if you go beyond that, yeah, that's illegal. Why? That spectrum is reserved for 5G. Same goes for UK, but UK is I'm saying, pardon me, America is 5925 megahertz to 7125. So huge chunk, like it's big chungus, meaning if you have a 6 gigahertz router from a proper brand who implemented this whole bandwidth, it's gonna be like, damn, like it's gonna be like, damn, the amount of throughput you can send in America, same hardware, would be exponentially better simply because of the law. So there is a certain level of region locking, so to say. Now be mindful, if you have a proper network, 5 gigahertz, proper implementation, more than good enough. It's like 6 gigahertz, do you really need it? Not really. Now that's why 6 gigahertz was used already for other functions like backhaul, radar and things of that nature. So 6 gigahertz is region dependent. Now, however, removing this 6 gigahertz does not mean, oh, there was no other improvement. There was not like, oh, I am just attaching one more. No, there is a lot of improvement. And that simply means those other improvement will also play a big role, even if you are in a place like, let's say, China or India or in Africa, where you do not have that luxury of using 6 gigahertz, you're still going to get some good chungus improvement. So let's dive deep into them. The first big improvement that every Tom, Dick and Harry is going to enjoy is multi-link operations, meaning MLO. What does that mean? That simply means if you have a certified and compatible device, and both of devices are using that MLO, you can have this puppy. What does this mean? This simply means your router is going to establish connection 2.4 gigahertz is good, go. It's going to establish connection with 5 gigahertz, good, go. It's going to establish 6 gigahertz connection, good, go. Here's the deal, it will transmit and receive in all of them. All of them. So for example, let's say 2.4 gigahertz, it can give you 50 megabytes per second. Okay, you have that pipe. 5 gigahertz, let's say it can give you 500 megabits per second. It's like, okay, got it. Now you have total 550 because both of them are working. And let's say you attach 6 and that can give you 1500 megabytes per second. Now you can attach all 3. That's the whole point. So if you hear people saying like weird numbers like 48 gigabits per second, yeah, generally they are assuming you are using all the links and all the links are orgasming to the maximum limit. Yeah, can that be done? Physics wise, no. To achieve that bonkers stupid speed, you need 2 routers because it needs multiple antenna, multiple radio. And to give you some context of it, your mobile phone can barely put 2 or 3. You need 8. All of them, like a receiver and sender, both of them need to have 8 of them. Now, does that mean this is useful? This is the most useful technology that you have right now. If you can use this will directly improve your experience. That's why I said this is the biggest simultaneous use benefit that you're gonna get. Why is that? Well, it can transmit and receive in all of them. It's gonna transmit, like it can even be smartly done in principle, where you can have like, hey, 2.4 gigahertz, let's send audio through it, 5 gigahertz, let's send video through it. It can be done. Again, I do not think nobody is gonna actually go down there and implement it, but it can be done. So transmit at the same time and receive at the same time can be done. It also allows very high throughput, meaning you can combine all of them rather than like, hey, 5 gigahertz is let's say 500 Mbps and you're like, hey, 2.5 gigahertz 50. Now you can get total combined throughput of 550. Now, like that does not matter. Imagine doing that 5 gigahertz to 6 gigahertz. There would be like significant improvement. So that combining can also work, which we call link aggregation kind of thing. And other options are also there where we have alternating. Alternating means it can detect, let's say if you have a lot of interference and it's like, hey, 5 gigahertz is very intermittent. That 2.4 gigahertz will be the backhaul. And then when it detects, hey, 5 gigahertz working, it sends data there. So it can give you a lot of real world throughput. On top of that, it can switch between them if needed. What does that mean? That simply means if you have older routers like this puppy, this router, even they try to implement this sort of feature smartly, where it will allow you to sign into all 3, basically 2.4 gigahertz, 5 gigahertz and 6 gigahertz. But here's the, even though it's signed in all 3 of them, it's only using one of them. It's either or, like you choose one, whichever you are using. Now, if you have Wi-Fi 7 hardware and compliance, you will sign into all of them and use all of them. So for example, I have 2 routers in my 2 floors. So ground floor has the Geo fiber router, very basic one. And then I have this one in 2nd floor. Now, when I'm going to the roof, the problem is I'm generally using 5 gigahertz. Okay, awesome, high speed GG. I go to roof, now it's concrete roof, so signal strength goes around. But it mobile phone tries to cling to 5 gigahertz. I'm like, bro, let 5 gigahertz go. Go to 2.5 gigahertz. It's far more range, it penetrates much better, and I can maintain my video calls and all that reliably without any issue. But it does not do that. I have to manually do it. Now, when you have this sort of MLO, it can calibrate each functions, meaning it's gonna like, hey, 6 gigahertz drop, no problem, switch back to 5. It's like, hey, 5 gigahertz drop, switch back to 2.5. That smooth roaming simply means you no longer have to worry about it. You will not notice it. It will switch all the, if it can use all 3, it will go YOLO on it. If it is like, hey, I have to let go of 6 gigahertz, okay, let it go. If it's like, hey, I have to let go of 5 gigahertz, it will let it go. It's like, it can do all of them simultaneously. So this will be the biggest impact that you will feel without actually noticing it. Meaning you'll just have a Wi-Fi device and it's like, it's just working all the time. You will not have to worry about like, oh, I'm switching from 5 to 3. Many companies did try, like even this has that like artificially implemented functionality. I forgot what was the name. They have that name where it will sign into both of them, and then a quick installation guide, I forgot that name. So TP link tether application or some other proprietary system, but this time it is implemented in all of them. So this will be the biggest impact that you're gonna have. Multi-link operations, direct quality of life improvement. Then we come to the other enhancement, radio level enhancement. So it will be using 1496 QAM. Now QAM is black magic. I do not understand it. To give you a context, the Wi-Fi 6 uses 1024 QAM. So basically how much radio slicing you are doing. So they have increased the slicing from 1K to 4K. Does that mean you get more data? Actually not. really? Because your improvement is only 20. Now be mindful, 20 is per channel. So that's significant. Like practically speaking, that is very significant. But you may be like, hey, we jumped from 1K to 4K. It's like going from 1K RAM to 4K RAM, and like its improvement is only 20%. Yeah, because once you start to slice too much, it also becomes too close to noise floor, meaning your signal to noise ratio drops. That's why there is a fundamental limit how much clean signal you can get. So that's why I do not expect like 4 times better throughput, 20%, and I'm pretty sure that 20% is optimistic. However, all the testing is showing that minimum 10% is there per channel wise. So grand total is piling up a lot. And that's why you cannot, even if you have 5 gigahertz of Wi-Fi 6, it will not be the same horsepower as Wi-Fi 5 gigahertz of Wi-Fi 7. So 20% higher data transmission per channel wise, and it's using 512 compression block acknowledgement block unit. So this is the biggest change. Now, like why? Every time your router is communicating you to your device, it's sending a packet where it's like, okay, now it listens to it. It's like, hey, did you receive it? So there is an acknowledgement packet received backward. So you have a link, doing. Now here's this works. That's why everything is reliable, everything works, everything is functional. Because that sometimes mobile phone can say, hey, let's say radio interference destroyed your packet. It's like, hey, acknowledgement did not receive. Then it's like, okay, I'm going to resend the packet. Now they have realized that approach was awesome in like back in the 1990, but it's not awesome in 2020s because our pipe is so fat, this is wasting time. So what they're creating is this 512 block, meaning now you can send a lot of blocks and it's going to compile all of them and then it's going to send acknowledgement, meaning instead of sending one packet and then saying I received it, it's sending let's say 512 packets and then saying yeah, I got it. So now like wouldn't that mean if let's say you have a failure and now you have to resend 512 packets? Absolutely. But that was the whole point. Our radio, modern radio is so powerful, so high efficiency, high throughput that this actually is a net surplus, and this will have the biggest impact on your feel, basically how smooth, basically how quickly your mobile devices can handshake with each other. It's like, oh, hey bro, we cool, we got this. This will have the biggest impact, more impact than QAM upgrade. So this will have improved efficiency and reduce wastage or overhead basically. So that's why even though your physical link could be like 5 Gbps, in older system it will be like good luck trying achieving even 3 Gbps, because again it's like sending back and forth just acknowledgement. Now that acknowledgement packet is made much smaller, so realistic throughput will increase from let's say in 5 gigahertz pipeline of 5 Gbps pipeline, it could go up to let's say 4.5. So you will have far more real world data transmission. And MUMMIO, which was the hype of the town, I'm pretty sure even this has this, yeah, MUMIMO. Now this puppy simply means multiple in, multiple out, and to multiple users. Because if you have older router, let's say Wi-Fi 4 router or Wi-Fi 5, yeah, Wi-Fi 4 and Wi-Fi 5, both of them, you can connect a lot of devices with them, but here's it was switching between them. Meaning, let's say you have a smart TV, you have a smartphone, and two people have smartphones, it's gonna go is slicing it. Basically, it's time slicing it. When you have MMIO, it can actually maintain parallel connection simultaneously, meaning it will have much better latency. Basically, it's not waiting for like, hey, come on, man, listen to all those two. And that's why like when you had a very cheap router and you connected a lot of devices, let's say smartphone, you have a smart home and you have way too many devices, literally connection will feel way too sluggish. Even though net speed is high, you will, because you are waiting for it going so for that reason, this MIO has been upgraded from 8 to 16. Now you can have 16 devices per access point where it can be like, I got this. Now it has to be a software thing. You cannot just like, oh, can't modern hardware handle more? Yeah, that's required by mobile phones, a tower. That's expensive. So going from 8 to 16 simply means now your household could have far more devices, and all of them, like it can detect, like it can prioritize, hey, smartphones prioritize absolute, smart TVs secondary priority, computers absolute priority, and then like light bulb, printers and all that, then it can downgrade those. So it will try to maintain all those 16 to the absolute high priority devices, and then like your refrigerator that requires Wi-Fi nowadays is like, bro, like you are not high priority. So that can be done. Now on top of that, they have also realized that wastage is, back in the ancient time, we had 40 megahertz of slice, a channel, single channel. Then it became to like, we stretched that puppy to 80. Now we can send more data. Then we stretched it to even more, to basically by 160 megahertz. That's in Wi-Fi 6. Now, if you have 6 gigahertz, they will stretch it to 320. Now, you're like, okay, isn't that awesome? That's absolutely awesome. Also, it's wasteful. It's like sending to every household a semi truck. Basically, instead of having a, let's say, how we have Domino's delivery, it's generally done on a 2-wheeler. It's stupid if you do use a 18-wheeler to transmit that much pizza. So that's why they realized this will be very wasteful. So they are using this, well, to a multi-RU. Intel had very amazing slides for this. So resource unit alignment. What does this mean? This has a puncher technology. What it will do? Fachang. So it's gonna have a, let's say, a channel that is dedicated to one device. Now because it's the router, it can say like, hey, that channel, let's say it has the capacity of 1 gigabit per second, and it's like the device is idling, it's not actually using it. It can be like, okay, puncher it. What does that mean? That 320 packet will be, you slice it. The moment you slice it, that remainder is now free to use. Now you have more channels to be dedicated to someone else. And this also means it can work in another way. For example, if some channel is like consuming more than what 320 can provide, it can attach to other things to be like, okay, I got this. So your gaming PC was like, whoa, it's consuming way too much data. Okay, let's make its pipe fatter, make other pipes smaller. So I really love the word puncturing. It's like, you puncture that puppy. So 40 megahertz, 80 megahertz, 160 megahertz. So I think it would be really wise if you have a light bulb that is Wi-Fi for some reason, put it on 40 megahertz. Don't waste 320 on that. So basically all these things will allow you to have much more seamless experience. You will not think about it. And this is the same thing, like 40 megahertz, how much data you can send. 160 megahertz, Wi-Fi 5 and 6, and Wi-Fi 7, 320. Now, again, you can understand it. If you are giving all of this to one device, you better be utilizing it. But again, you can't guarantee it. So, puncture that puppy. You're like, you're going to cut one of them and send other to other one that is using it. So these enhancement will improve the most. Rather than going from 5 gigahertz to 6 gigahertz, this will give you the biggest oomph, where it's like, hey, my packets are coming in far more reliably. Why? Because bulk acknowledgement. Hey, I'm getting bit more oomph. Why? Because you have frequency is utilized bit more efficiently. And again, you have multiple devices and all of them are feeling smooth. Why? You can maintain 16 streams. And again, when you have heavy users, like let's say you are watching 4K Netflix stream, which is very low bit rate nowadays. But let's say you are doing it, and then computer's like, I got you, fam. Slices it and then allocates it efficiently. So same spectrum, same capacity in radio waves, but you're getting far more usable quality experience. So these are the enhancements in Wi-Fi 7. However, let's come to the brutal part of it, the cost. Here's the deal. If you actually read paper, the white paper of it, you'll be like, the Wi-Fi router is way too goddamn close to this puppy, as in the 5G mobile cell tower. The technology that is utilizing in there, almost all technology is in this goddamn Wi-Fi. That means fundamentally the complexity of like the old Wi-Fi router, it was a very dumb device. It was a simple device. So it was not very expensive. It was like a chump change. However, when you're talking about this level of device, it's expensive. Why? Because the task needed is fundamentally complex, meaning you are going from let's say 100 horsepower engine to 500 horsepower engine. You are jumping to 50,000 horsepower. Like you are literally jumping from a car engine to a container ship engine. Fundamentally, on a physics level, how many calculations needs to be done? Like they upgraded from 1K slicing to 4K slicing. Fundamentally understand that that's happening every second. So you just amplified the computational requirements. So silicon, basically the application specific integrated circuit, ASICs that are needed for that, they are very expensive. They're proprietary because they are only used for this. It's like a very specific device. And like, wouldn't mass production will reduce the cost? Not really. Like there is a fundamental limit. Like if you want more, you have to spend more. Like back in the day, we had to spend more for GPU. Fun fact, we still spend more for GPU. It will always scale up like that. It's like same thing. Like if you have a 1,000 horsepower engine versus 10,000 horsepower engine. Like there is a physics-based scenario here. It's like if you want that much slicing, that much communication, that much stuff, the silicon that can do that on a radio level is like, it's not that we can't do it. That's what mobile towers are for. But that's mobile tower. It's not cheap. So fundamentally, it would be very expensive. And consequence of going all in, The power draw on the routers are bonkers, meaning many of these routers, if they are designed properly, they have a lot of heat sinks. Yes, you heard it right. Instead of back in the old days where you had like, plastic box with a PCB, you have cooling, you have heat pipes, and I'm reasonably sure some companies will literally bring one that is too small, and then they're like, wait a minute, why it's making sound? Oh, it has a fan inside to keep it cool. As in, like, you will go from power consumption of 4 watts or 10 watts to 40 watts. Even 50 watt is viable, like continuously. So these things are getting hyped, and the power draw is huge. And it will have an impact. But for example, let's say you are talking about a hotel where you have access point, like you could have, let's say 50 access point. If all of the power draw just quadrupled, yeah, your energy bill on your power over Ethernet will be like, bro, relax, bro. We can't pump that much energy. So there is a very serious consequence of the cost. Like amplifying that much stuff into it, yeah, it will hurt your pocket. Like this is the cheapest I could find in India. That was like 42,000. To give you a context, that's a PS5 level cost. Let that sink in. It needs that much horsepower. And yeah, fundamentally, like if you understand the radio level, it's like, damn. Like it sounds very easy. Oh, we're just gonna take the radio packet and we're gonna slice it. It's like, think about it. It's happening almost at real time. Millions of a time per second. Bonkers. So power draw would be huge, and most of the time we're gonna get very cheap implementation. Why? The radio chip itself would be the most expensive one. So what they're gonna attach it to, like that radio chip, like when you see Snapdragon giving you a breakdown of their chip design, SoC design, there is a very small section that is for radio communication. That will have the most amount of silicon for that radio hulala. But fundamentally, if you have a router like this, the board can only support so much oomph, where it will be like, bro, I get it. You want that Wi-Fi 7? Okay, we're going to give you the chip. The SoC behind it, that was actually managing the data layer, it will be like, yeah, I can't actually pump that much oomph. So we're going to get very serious implementation where it's like the radio is like, GG. The thing that drives the radio will be like, bro, I'm like, man, relax. And I do understand. I think that's why the cost is going so much higher. Compared to Wi-Fi 6 and 6E, these things are almost 2 times more expensive. So I think somewhere somebody is realizing, hey, we actually have to put very expensive SoC, because here's the, at this scale, at this sort of gigabits per second, the routing part becomes the expensive part. Meaning, can you do the radio stuff? Yeah, that's an ASIC. Once you have mass production, it should be stabilized in cost. But here's the deal. To handle a scenario where you have 10 Gbps of data throughput managing reliably on multiple clients, you need something like this. Like if you looked into enterprise grade hardware, enterprise grade servers, they will always specify like in Gbps, like, or we can handle 50 Gbps. Old days, nowadays they will start at like 200 Gbps, 500 Gbps or TBps. But here's the deal. Your basic box is also claiming that. Like your basics box now are claiming, oh, we can do 48 Gbps. It's like, no, you cannot. 48 Gbps of data packet handling, even with few clients, it's a very computationally heavy task. Like if you actually have multiple heavy clients where, let's say, you are doing something heavy in mobile phone, let's say gaming. Gaming is not that heavy, but it is latency sensitive. You will notice it is like the SoC that is in this box would be like, yeah. Again, if you are like, tech user, where it's like you are the techie one, nobody else will notice. But if somebody is like buys this for their office, they're like, hey, this is expensive, it should be good. And let's say 10, 20 clients are using it at the same time, they're like, bro, no. That's the reason why this sort of devices, like which is a almost full-fledged high-end computers are used. Only then you can process data packets at that speed. So there is a serious issue, meaning it's a good idea, like let's put a 5G mobile tower in your home, but it's like, is it really like, are we there yet? Like, are we actually there yet? Because here's the deal. I can tell you, most of us, we do not have this level of horsepower in silicon where you can just like, hey, I'm just going to plonk that SoC on there. Are there SoCs that can do that much crunching? Like 40 gigabits of crunching? Easy. Just don't ask the price. So that's the cost part. So do expect these things to be very expensive. And worst case scenario, if somebody is cutting too many costs right now in the year 2024, by 2026, this will become even more expensive. If way too many people notice, hey, you're selling like Wi-Fi 7, I'm barely getting that speed because the SoC behind the radio is getting saturated. And be mindful, there are some places on this planet that are giving more than Gbps fiber connection. So you may find people using this in office and then they're like, not as good. So what should we do? Well, first thing, wait at this point in time. So you have to ask yourself, how many of you actually have more than 100 Mbps reliable, stable connection? Yes, let this be very clear. Some people get too fast speed. So whenever you see the worldwide graph, it looks like, oh, everybody has like 200 Mbps in USA. And most people will tell you, no. It's like, is the reason why that graph looks so weird is like some people who can get high speed fiber, they get bonker speed fiber also. Meaning, in my case, I have fiber to home. I can get 100 Mbps. You're like, damn, that's good, because yes, the broadband definition is 25 Mbps. By 50 Mbps, you can run almost all application. So, okay. How much I can get? Like, again, it's home connection, nothing fancy. I can get 100 Mbps, good. I have 300 Mbps connection because 100 was like too little. I do upload a video every day, 2 times a day. So I do need a bit more oomph, the uptime. And so I've upgraded to 300 Mbps. There was no 200. So I had to upgrade to 300. I can go to 1 Gbps in household connection. Individual, basic internet, and it's not even expensive. I can go to 1 Gbps. Some people can easily go to, if they have direct communication, 10 Gbps in India, middle of nowhere. So in those sort of scenario, you have to understand, only few people have that luxury. Yeah, that means around 180 cities in India, but not every single city in India, especially in villages. Like only few villages have optical fiber now. So same applies in USA. Like some people who can get it, they get bonkers, like 8 Gbps connection. It's like, bro, there's so many people who are not even getting 25 Mbps. So that's why, be realistic. Do you have that sort of stable internet? And the most important part, do you have user count? Because you could be like I'm an individual, like I was techie individual. I have like GeoFiber router, then I connected this one on my second floor, and I'm making sure I'm getting very awesome internet speed on my mobile phone. But here's the deal, I am the techie one. Nobody else needs this sort of horsepower. My mom, my dad, my brother and sister-in-law, all of them like does not need that sort of oomph. But same applies for your household. So this idea of 16 simultaneously, do you need it? So that's why. And as of now, in 2024, all the hardware that you are receiving right now, they are made before the standard was finalized. So fundamentally, there was a feedback missed. Hopefully, ideally, all it would require is a lot of firmware patches in the early releases, as in like 2024. By 2025, you should have actually get real hardware that is finalized to deal. Like it won't require any rework. So we are expecting a lot of mess ahead. However, because of the modern pipeline, because of the over-the-air updates, you should not worry about it. Meaning, even if you have a, let's say, Wi-Fi 7 mobile phones, which like Samsung Ultra, Samsung S24 Ultra has it, OnePlus phone has it. You can buy a few routers. You can buy for your PC Wi-Fi card that has that SoC that is qualified for Wi-Fi 7. It was made before the standard was, solidified. So do expect them to work, but do expect them to require a bit of firmware update. Again, if it's automated system, you will not even notice it. So here's the, what can we do? 99% of people will benefit more from getting a mesh network rather than having a super expensive Wi-Fi 7 one. So for example, right now, in most household, you will only find one of this puppy. Like even in my household, I only had 2 of them. So many times you may find, hey, especially if you are in a heavy household where you have like 10, 20 people, or PGs where you have like 15, 16 people, hotels, hundreds of people, guest house where you could have 30, 40 people. In those sort of scenario, you will be better off if you have a mesh network where you have multiple access point. Thankfully, all companies like this is TP-Link one. TP-Link always specifies their one brand, that is one mesh network, meaning I can buy multiple TP routers, different models. As long as they specify this one mesh, I can connect them over Ethernet or Wi-Fi and just activate a setting, and it will make a mesh network without me requiring to do anything. Same goes for Asus also. Asus calls it AI mesh, if I'm not mistaken. Other brands also have something similar, meaning it's today's day and age, it's not complex. Back in the day, it was really complex because Wi-Fi roaming is really tedious. So having this sort of implementation is far more useful. Even in an office scenario where everybody is working on a laptop and they require direct access to the main server, you may find this will be far more pleasurable, far more cost effective. And if you really want to improve experience, especially if you have multiple heavy users, get this. What does this mean? This simply means a computer that is your router. The biggest weak link most people have, it's not the goddamn internet, it's the router. Especially if you have multiple people. Even if you have multiple devices, the router, that's why I specified, the cheap implementation is far more impactful compared to like what we will think. Will they, oh, we have Wi-Fi 7 or Wi-Fi 6? It's like, no, if you have a crappy router, you have a crappy router. So to give you a context, many companies, if they get let's say 1 Gbps fiber connection, and they get that fiber router where they cannot just pull out the fiber and put it into a SFP port. Let's say many companies lock it. Okay, no problem with that. What they will do, make the router, that fiber router that is from the service provider, set it into bridge mode, and just the end is just a bridge router. Basically, from their point of view, it's a converter from fiber optic to Ethernet, and then they set it to their custom computer, which is a full-fledged computer. Even a few-year-old computer is far more powerful compared to your ARM SoC that is on your low-cost routers. So there you can do a lot of heavy work. What kind of heavy work? Well, imagine this way. You can actually handle multiple users doing multiple throughput tasks, heavy throughput tasks, without any issue. You can data log all of them without any issue. You can do very deep level basically ad blocking on the router itself. You can do a lot of filtering on the router itself, and you will thank me. Every company that is like, actually in the mid-range where they do not have the money for that Dell router or like, Cisco router, they do this sort of thing. And thankfully, this has become big enough ecosystem where there are companies that are selling just PCs that are custom built for that pfSense router and all that. They call pfSense box. So you can buy them, and then you will be like, holy damn, this my internet, same internet. You will get much better real world experience. Why? Because the router won't be choking. Heck, in my scenario, the router is so garbage, I have to restart it every few days. So that will be far more cheaper, far more effective. Get a proper router, get a mesh network setup, and you will thank me later. I can guarantee you that. Compared, again, assuming if you are in one of those scenarios where you have internet, because be mindful, there is another choke point. Does the server that you are accessing over the internet has that sort of throughput? Most servers do not have 1 Gbps of throughput. Again, they cannot afford it to, like, Netflix does not actually benefit from it. Netflix would be far better. It's like, hey, if our basically a data stream, 4K ultra high resolution data stream is only 550 Mbps, they will only give a lot, quote unquote, 60 Mbps per customer. So there is some bit of buffer in case of downtimes and all that. They will not be like, okay, if some customer has 5 Gbps, give them the 5 Gbps. They will not do it. Fundamentally, they won't do it. And same will happen with Steam also. Even if they can do it, they won't do it because they have to service millions of customers. So there is a fundamental limit. Do you actually need multi-Gbps server system? And again, if you have like local area network, connect it by wire, and you will thank me later. So this is the time where we wait for 2024 to pass, and then you make a decision. And if you have to do it right now, get into any of this sort of mesh network, thank me later. You have an office, buy a freaking pfSense box and make it in a proper router. Trust me, the learning curve is painful, but you will be grateful to yourself where it's like, oh, now I can do so many amazing things. So this was my presentation on Wi-Fi 7. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.